I'm going to show a little bit of code, but not too much. In general, I'll just try and talk about some of the general things that we found while using Clojure. But when I do go over the code, I'm going to try and be a little bit specific about why I think Clojure is good at certain things. And if you have questions about the code on the board or on the screen, please ask. How many people here have actually used Clojure and have some idea of what it looks like? Okay, so a few. So I'll go slow over those examples, and if there's still something you don't understand, please ask. My name is Ignacio Thayer. I'm CTO and co-founder of a software startup here in Silicon Valley just down the road called Ready for Zero. Our goal is to help people get out of debt, and we do that by providing them tools and motivation and decision-making assistance, all automatically online, so that they can understand the impact of their decisions to eventually get out of debt. We came out of the summer 2010 class of Y Combinator. At that time, we were just 2 people, myself and my co-founder, Rod Ibrahimi. And now we're 11 people. And all of our back-end code right now is written in Clojure. We have about 5 engineers out of those 11 people. And so this is basically kind of walking through our story of discovering Clojure and a few of the things that we've learned. And our story is a little bit unique with regard to Clojure in regard to building a web application, because we actually built the first version of our site we launched with Django. And so I can bring a little bit to bear about comparisons with Django and Clojure and some reflections on the differences between the two. And one thing I'd like to say is I'm not a programming language zealot, so I use whatever works. Before I started Ready for Zero, I was at Google, where I programmed with C++ and didn't really have a problem with it. But now, obviously, I'm a big fan of Clojure, and I think it's actually one of the most powerful languages out there today. So in general, through the talk, I'd like to address some of the things that are commonly seen as warning signs or hazards of Clojure. I hear a lot of the same things about Lisp in general, that, macros are really dangerous, or S expressions are really complicated and no one understands them, or it's really hard to learn, or you can't hire people. Right? Those are the kinds of things that I've heard over and over again that really just haven't been proven out. And I'd like to be a little bit specific. Like I mentioned, I'll show some code examples, but not too many. And so I hope at the end of this that the people who haven't tried Clojure have a little bit of understanding of what it takes to actually launch a real website using Clojure and have a motivation to try building some more serious applications. I know a lot of people dabble with it. And for those that have used Clojure, I hope that you take away something also and actually can learn from the best practices that we've built up over the last few years. And for myself, I'd really like to get better at articulating why I think Clojure is good. So please give me feedback at the end. I'd like to get better myself. Okay, so at the beginning, this was summer 2010, we had a 2-person team, and we entered Y Combinator. And we entered Y Combinator with a prototype of a Twitter news reading app, which is a little bit different than what we have today. We got in with this prototype. It was kind of a neat little product. People liked it. People used it. It was sort of a replacement for RSS, but on Twitter and leveraging your social graph. Pretty new concept, I guess. I'm sure you've never heard that before. So we built this, and it was fun, and people liked it, but we sort of asked ourselves, is this a real business? Is this solving a real problem for real people as opposed to Silicon people in Silicon Valley? So anyway, we started thinking, and we started asking around, trying to just brainstorm and talk to people in the real world and see what problems they had. And we ended up stumbling upon the fact that a lot of people have debt, which you may or may not know, depending on if you live in San Francisco or not. San Francisco is sort of a bubble. But anyway, we sort of figured this out, and we had both been in debt before, my co-founder and I. I had student loan debt. He had failed startups that he still was paying off. And we realized this was a really big problem. And so we had the problem. And so then we went out and started to find a solution. And at the end of summer 2010, around the end of Y Combinator, we were starting to build prototypes. So we built very, very quickly. At this point, developing clean code or making it so that you can reuse pieces of your code is not an issue at all. What's really an issue is validating what you're doing. Right? You need to build something that's going to be around in a few years. not necessarily from a coding standpoint, but from a business standpoint, and that requires really fast iteration. So we were really aggressive about releasing things and having people use our early prototypes. Okay, so basically, yeah, we weren't concerned about building clean code or even any conventions or anything like that. All we wanted to do is release very, very quickly. And myself, coming from Google, I'd never built a web app before, and so this was kind of a new experience for me. And I just needed to get stuff done really fast. And so I looked around at the options available at that time, and obviously Rails was very, very popular and great for building web apps. For me, it didn't seem like a great fit. I'm a huge fan of a convention in general, but it seemed like Rails really forced you into certain conventions without your consent, and then as soon as you wanted to break free from those, it was very, very painful. That may or may not be true, but that was my impression, so I looked for something a little bit different. I actually tried some Node.js stuff, so I actually tried to build a little version in Node.js and realized that that was more JavaScript than I ever wanted to write. And then actually turned to Django and immediately was productive in Django and really liked Python, and so we built our first version in that. And I was immediately productive in Django, which is something I have nothing against Django. I love it. And that leads me to my first reflection is that frameworks, I mean, Gareth was talking about them a little bit earlier, they're really good at what they're good at, right? They make easy things really easy. And that's a little bit unfair because they make some complicated things easy too. Things like the things that later on we'll see are sort of lacking in the Clojure community right now. Things like ORM, right? That's not something that's simple. Building a performant ORM is hard. And the code, one thing I liked about Django is that the code was really easy to dig into. So you could actually read the code, right, and make changes to it, understand what was going on, understand why certain things broke, why they didn't. And one thing that I really loved about it, actually my favorite thing, was that it was extremely Googleable. So if you didn't know something, didn't know how to do something in Django, so I don't know, you want to make it so that cookies are secure. Okay, well, in 15 seconds you can copy and paste that because you searched on Google and found it. That was actually wonderful. So it's sort of like stepping into a furnished apartment, right? Like you just walk in, hey, there's a couch there, a TV, I can just make myself at home, and hey, someone picked out the curtains, that's great. And it's relatively simple at the start, right? I think because you're not dealing with the murky corners of your framework, or you're dealing just with what the framework is for, there are actually little sort of complication, right? Your code is not touching a lot of things that it shouldn't be touching. So it's relatively simple at the start. And then, which is a common sort of drawback of frameworks that I think people understand, is that their advantages start to run out, right? As you progress beyond what the framework is for, as your application starts taking twists and turns, as more of your code is not supported by the framework but is application level code or has to go outside the framework in other ways, they become handcuffs. But it is important to note that I think the areas right now that Clojure is weakest is SQL data modeling and SQL database tools. So a great example is database migrations and managing schemas. So for that, even today, 2 years later, we still use Django models and South, which is a tool for Django to do database migrations. We still use those today because it's not something it's not very fun to build that kind of stuff, and so I think no one's really spent the time to do it, and it has to be done correctly. That's not something you want to screw around with. I mean, I think the one thing which is holy, even though we were building things very quickly at this point, is that you don't want to screw up your data, and you don't want to deal with corrupt database or any time that you want to change something that it's really hard, right? Because then things that are hard you tend not to do. I think that's a valid criticism of the state of Clojure Web today. But anyway, so stepping back a little bit, right? So so we were building at the end of November at the end of 2010. Am I talking at a reasonable pace? Because sometimes I talk really fast. Okay. So at the end of 2010, we were building very, very quickly. At that point, we were a team of 4. I was still doing most of the back-end development. Everyone, including our designers, were doing light JavaScript and coding templates and things like that. They're very excellent designers, and my co-founder was doing some light coding as well. But I was the one doing the bulk of the heavy development. And so during this time, we were really iterating extremely, extremely fast. And by that I mean performing all of the cardinal sins of software development, writing things without tests, ripping things out and putting them back in very quickly. I've since repented for those, and so please don't judge me. But anyway, so we had Django and jQuery soup. And so has anyone here actually written jQuery soup or had to deal with jQuery soup? It is really painful. But anyway, that's what we created. And I started noticing that there were some really common bug patterns that emerged. And I'll talk about the most common one, which persists today, even in Clojure. So the most common bug that you find manifests itself as a non-existent key. And usually that's, at least in my experience. And that's usually because there's a mistake or a misunderstanding in what data structure or object you're being passed. So in JavaScript, has anyone had an undefined error in JavaScript? Okay, well, all of the rest of you are lying. So Python complains about attributes not being found. And so one thing I noticed in my Python code was that I was using has attr everywhere. Basically, it checks if an attribute exists. And in Clojure, this manifests itself as missing keys in a map. And I think this is just a sort of a fundamental problem of dynamic languages in general, because you build things up very quickly without structure. And then you forget what the structure is, or the structure becomes unintelligible, or you haven't communicated the structure well enough to somebody else on your team. So stepping ahead again a little bit, let me talk about some of the ways that we've addressed this particular problem in Clojure. So one way is with contracts. So we use a library called Tramel to write contracts for, you can write contracts for functions, for other Clojure primitives like records. But here, this is an example of a function which implements a contract. So normally, the way you define a Clojure function is with defn, D-E-F-N. But here, Tramel provides a def constrained function form. So here we define a function, call it create client. Right, and this creates connects one of our users to basically a bill pay client where they can pay their bills online. And this takes two parameters. One is a user, the other one is some parameters map, which has some options in it. And here, this is a form that Tramel adds to this def constrained function. So normally, a Clojure function looks basically like this, where you have the arguments and then you do stuff. And Tramel adds support for this form. And this form basically checks some attributes of the input parameters. And this can be whatever you want. This is basically free form, but this is saying this is what checks I'm going to perform on the input, and then this is the check I'm going to perform on the output. And you can have multiple ones here also. But one really nice thing is that this is not just checking stuff. This is actually live documentation about what this is getting. And it's dissimilar from a type system in the way that you can be really expressive with what this is checking, right? So this is actually checking content here of date of birth to make sure it's actually a date. And you can add these things later on when you decide to. At the beginning, if you only have very simple maps and you decide that it's not worth it to go ahead and type all this stuff, then you don't have to. You can just add whatever you want to a map into the parameters, and you're good to go. But as you start, as the team starts to grow, it's good to start checking these things and adding them, and you can sort of add it a la carte when you want. Another example of how we've sort of addressed this particular problem, again, there are other problems with dynamic languages. This is one that's just very common. And so here we have checked threading. So in Clojure, there's an operator, which I'll talk about in a little bit more detail later, called a threading operator. And suppose we have a map here. X is a map, or hash, that has a key y, and y's value is another map with a key z and value 1. The threading operator lets you sort of thread through this and say, okay, given x, apply the y function to it, colon y, which in Clojure will return this map, colon z1. It'll get the value of y. And then look up the value of z in that result, and you'll get 1. Is that clear? Are there any questions about that? Okay. So suppose then that you think that, oh, the key q should be in this map, and you thread and get that. Well, Clojure will happily return nil because q is not in the map. So that could be a problem, right? If you actually think this should be there, then and suppose this is some value that's going to get passed somewhere else, and then this manifests itself in JavaScript in that something is undefined, and you have no idea how it got there or why it's executing this function that's not there. But so if you want to really assert that it's there, we created this little very simple thing that will check that each one of these is non-nil all the way down the line. And so if you try and do this with this dash exclamation point greater than, you'll get some exception that says, at this point I tried to evaluate it and the result of getting Q is nil, and it shouldn't be. So these two examples are somewhat simple, right? And the problem itself is somewhat simple. But one thing that this really demonstrates that's powerful about Clojure is that if you have a problem, you can sort of modify the language that your team is using to fix it, right? And that is really powerful. And I'll show some examples later on. So anyway, back to our story. It's summer 2011. We've launched our Django app. We're starting to get users on the site. People are liking it. We're making changes pretty quickly. And at that point, I started using Clojure. And so at that point, I had done some stuff with Clojure before. Usually, I had done some natural language processing stuff in it. But here, I actually used it for a work purpose, right? So it was more critical that I actually be productive and get things done. And I initially used it for analysis. So we store all our events in Mongo. So basically, we use Mongo for analytics. And I started just looking into it to see, who was using our site, what were they doing, what were the types of behaviors that we were having people do on the site. Were they using this feature, were they using that feature, were they getting out of debt, were they not? And at that point, I really fell in love with using the REPL. And Python has a REPL, right? But this one really seemed to be different somehow. And this led me to my third reflection, is that the Clojure REPL really is a delight compared to other languages. Right? In general, REPLs let you build code up. Right? You can evaluate code, see that it's working, and move on to the next thing. And you can use real data. So you can connect to your real database, which is extremely powerful, and run some tests. Right? So you can run some code, see what the output is, make a change, and then see what the new output is. That's extremely powerful. REPLs let you do this in general. So what's different about Clojure? Why is a Clojure REPL really that pleasing to use? Well, I think a couple of the reasons that I can think of, and perhaps more. But one is that with S expressions, the sort of syntax of Lisp, this syntax is composable really, really easily. So let's say that we start here. This is my little REPL prompt. And I map across all my users. I get the date that they joined the website. And so here you have some list of, I don't know, say tens of thousands, hundreds of thousands, millions, whatever users you have of the date that they joined. Well, suppose that you're actually interested in some query after Christmas. Well, you can take the exact thing that you just wrote and plop it in here with you don't have to format white space, you don't have to do anything else. It's just a very simple operation that if your tools support, it's one or two keystrokes. And it may seem trivial, but that kind of stuff keeps you in the flow of answering your question and working through your problem. So here you have a new result, and you say, great, how many are there? Well, you can then take exactly that, plop it in to this function count, and get the count. And suppose you actually want to use this on some web page or something, you can just take this whole expression again and plop it into your code. And there are again, you don't have to worry about that, that if is, has some white space at the end of it, like you do in Python, which I know people say is not an issue, but it still aggravates me. But it really is extremely fast, and it is much faster than other languages. Another thing that's really a delight to use with the REPL is the fact that Clojure has a few operations, and generally you see the Clojure set of functions or the functions that are in Clojure core, the core part of Clojure, are really well thought out. And these two in particular, threading and the next one that I'll talk about, thrush, let you sort of build up statements extremely quickly in the REPL. So in the example that you saw before, I sort of made the point that you could stick things into the end of functions and you could just sort of grow functions like that. Well, after a while, it becomes kind of unintelligible. And I think that's one of the things that people sort of think of when they look at Lisp code. They said, well, you have to read this code backwards, and it's really not clear what's going on. Right? Does anyone feel like that? Has anyone heard that argument before, that you sort of have to read code backwards if you're reading Lisp? OK. So this lets you write it forwards. So I'll show you. I probably should have rotated this, but I'll show you an example, the previous example written more elegantly. But here, in this example, let's say we have this map of a user. Right? We can instead of writing forms around it, so instead of, let's say we want to add 2 keys to it, we want to add logins and balance to it. Well, we could use the Clojure function assoc, which assoc takes a map, a key, and then something to add uses the value for the key and inserts this value with this key into the map. So we could do that by writing these expressions in a nested way. Start with the user, add an assoc around it, and add another assoc around that. But this way lets you write it in a way that's sort of forwards and extremely readable. And not only is it extremely readable, but if you want to add more stuff to it, you can just tack it on at the end. So you can write this in your REPL, see the result, say, yes, that's what I want, moving on. Write something else at the end. You don't build up these really kind of uncomfortable expressions that I was even doing in Python. So I don't think this is a thing unique to Lisp or Clojure. In Python, a lot of my code ended up being sort of functional anyway, and I sort of had this problem where these expressions got kind of out of hand. Now, you could say I probably shouldn't do that, but, well. So here, what this does is this takes user, puts it into the first argument, and then this assoc adds logins by getting the logins. And then this threading macro takes the result of that expression and puts it again as the first argument. And then this associates the balance into that map. And at the end, you get something like that. Are there any questions about threading, or what I mean by concatenative programming? No questions. Has anyone done concatenative programming before? Never. Who thinks it's a silly idea? No one. Who thinks it's a great idea? Okay, cool. So the next, let me go back to the previous example that I had. So the thrush operator is very similar to the threading operator. So the threading operator inserts the first argument inserts the first argument as the first argument of the second argument. This one inserts the first argument as the last argument of the next form. So here in this case, note that you could also use what? You could also use the threading macro for this one because there's only one argument to this function. But, well, I don't have a great example of that. But so here, if you count the number of users, you have 1,000 users, right? And let's say you're in the REPL and you want to answer some query about something. So you start with 1,000 users and say, great, I have 1,000. That's my start. OK, let me look at a few of them, right? So what is this data structure that I'm looking at? Let me inspect some of them. This is really, really important in general when you're working with data. So we had this problem even at Google, where we would run distributed jobs across tens of thousands of machines and sort of wait for the result. And no one had any idea what was going on in between. And so many times we would have to build tools to sort of explicitly log things so that we could inspect them. But feeling your data, right, actually looking at it along each of these steps can really give you insights about what the heck is going on, right? You realize that, I don't know, the iPad user agent is the same as the iPad mini user agent, right? This is stuff you get at by just kind of looking around and swimming in your data a little bit and understanding that, what are the actual values that you're working with. So in any case, so here we have 1,000 users, and let's say I want to look at 5 of them. Well, I can write this form. So take my 1,000 users. Clojure has a form called take, and so I take 5 of them, and then I print them out by mapping print them. Okay, and then I get some stuff, and I can look at that. And this form we've made a nice little compact wrapper around, so it's a little bit easier to work with. You don't have to write so much stuff, but I just wanted to keep it simple here. And so now you can move along and say, great, I've seen those 5 users. Now what do if I want to look at the dates they joined? Well, what format is that in? What does that look like? Are they all non-nil? So users, I can get the date joined, take 5, and then print them again. And so I can just plop this form here in the middle. And again, I'm looking at the output at each stage. And then here, for example, I can add a filter. So users get the date joined and then filter those after Christmas. And then I can count those. And again, I can copy this whole thing and put it into my program somewhere. So this is very similar to, is anyone here really comfortable with Unix tools? Things like grep, awk, sed. Okay, so this is very similar to that, right? So one thing you might do is you might write a Perl one-liner that transforms a line in some way. Well, what's the first thing you do? You look at the first 10 lines of a file, and did that work? Great, moving on. You add the next thing through a pipe. This is very, very similar to that model. Okay, so after doing this for a while, I said, hey, the grep was really great. But I'm using for this analytics. Is this clear? Are you giving me a confused look? Or no, okay. So the REPL was really great. I was using it for analytics. And so I thought, wow, it's cool that I can do this here, but I can't really write any of my code in that. So the REPL sold me, but we were still using Django. And I'm going to speed up a little bit. I might skip some slides because I think I'm running a little bit slow. But at that point, right around June of 2011, we raised the Series A and started thinking forward about growing a team, about all the stuff that we were going to build. We have really great designers who had really great, after talking with users, had really great visions of things that we would do. And I looked at our code base and I said, there is no way in hell that I'm going to be able to build this on top of jQuery soup. So, I thought a lot about it, and I looked at our Python code also and said, wow, this is really starting to get ugly. My code had started developing a really functional style, and it just wasn't fitting with Python. Python I found to be extremely verbose. And so I started saying, well, I wish we could use Clojure for our app also. Another thing that was really important, right now that we had some money, we could grow our team. And anyone who's tried hiring people right now, has anyone tried hiring people? Is anyone having a hard time hiring people? Yeah, okay, everyone. So it's actually really hard to hire people, right? And so, right, this brought on two questions. Well, can you hire anybody that knows Clojure? Does anybody know Clojure? And then not only can you hire them, but can you hire a sufficient number, right? So I've heard the argument also that, well, okay, yeah, you can hire 1 or 2 people, but can you scale your team to 100 or 200? Well, just to ignore that problem for now. But I realized that if we chose Clojure, we would be really attractive to a certain type of people, right? We'd be attractive to people that are curious to learn new things, right? Not curious to just learn the newest technology, but actually curious to try something different than they had worked with before. It's sort of like being a contrarian investor, right? Like if everyone is doing this and trying to get Python developers, well, if you can go over here and attract a whole new segment, it's actually pretty attractive. And that turned out to work out really well. So our first hire was a guy named Chris Granger, who's since gone on to found Lighttable, which is a pretty popular project. I think it's actually the most popular post on Hacker News, was his Lighttable announcement. But we hired him, and at that point, I said, well, we've got this really good guy, and not only him, but a lot of other people expressed interest also. And so that sort of sealed the deal. And I said, these people are really high caliber. We're getting a lot of interest. Let's go for it. This was a hard decision to make, though. One thing that really made it easy for me was that there's always, with new languages, the perennial or chronic question of libraries, right? Well, does it support the right libraries? Two things ameliorated that concern. One is that a lot of services now are REST-based APIs, and working with those in Clojure is sweet harmony. And the second one is that there are libraries for core things, right? So I'm not going to have to spend a day writing a standards compliant JSON parser or worry about how CSV is escaped, because there are Java libraries for these things. And worst comes to worst, I can just go grab one. And so that really mitigates the level of risk, because when you're trying to release stuff every day, you don't want to take 2 days off so that you can, I don't know, build something kind of arcane like a JSON parser. Okay. So our web app, and I'm at 30 minutes. Okay. Our web app. So basically, our web app looks the same today as it did back then. We have the same structure. We use Noir, which is a pretty popular web framework, again, authored by Chris Granger, who was our first hire. We use Korma, which is a SQL abstraction layer that he also wrote, partly because of the frustrations of using the library that we were using before. This is actually much nicer. It's still not an ORM, so you still have to do SQL, and you still have to kind of understand SQL and do the joins yourself. That, I think, is not ideal. So I'm not really a SQL. I haven't used SQL that much. And so to me, that's actually not natural. We use Postgres. We use Mongo for analytics only. I actually, say what you will, but I don't trust Mongo with non-analytics data, and I don't know, I might get fireballed for that. And we also use Backbone.js. And it's worth noting here that out of all these things, managing stuff in Backbone.js is actually much harder than anything else. It's crap, someone says. I don't know if I don't want to hurt anyone's feelings, but it's not. I don't know if it's crap. It's just JavaScript sucks as a language. Okay, so as the code started to grow in Clojure and we started to build this web app, we started to write more and more code. And again, we were kind of starting with this really fast iteration and writing things kind of off the cuff. But even with 2 people really working on the back end, it became more difficult to communicate about data structures. And we started to try and enforce things that would communicate better within the code. And one of the things that I realized is that the point of writing code and of communicating your code is not that it's particularly, you don't want to make it verbose. That's not the goal. Nor do you want to make it tiny. That's not the goal either. The goal is to make it understandable, right? To digestible. And so for me, the verbosity of Python didn't necessarily make things understandable, nor did writing millions of one-line functions, sort of the way some people advocate that you should write Lisp. That also, to me, was not comprehensible. So I think what we learned was that you should use the expressiveness of the language and the power of the language to make things comprehensible. And it seems sort of obvious, but in other languages, it's actually kind of hard to do. And I think one of the things that makes Clojure really attractive, and the reason people say, I've heard this statement that's extremely vague, that Clojure is great at abstraction. Well, that is a pretty vague statement. But I think one of the reasons that's true is that at the end, when you're done building something, it looks exactly how you want it to look. And it doesn't contain any extra stuff. And it doesn't contain any more stuff, at least if you've done it right. And the syntax is a big part of that. And the syntax is something that other languages, many of them, aren't able to really change. And I showed a few examples earlier, and I'll show some more. Another thing that's important is to keep namespaces clean. So just like you would define private methods, or you would define in C++, say, your header file in one place that describes your interface and the implementation of that interface somewhere else, I think it's important to follow that practice in Clojure also. OK, I'm going to, OK, I'll do this one. So a few of the things that we've done to sort of advocate code as communication is, here's one example that we built this sort of very small DSL, didn't spend too much time on it. I don't know, 10 minutes was probably the first version. But this basically describes what an endpoint looks like. So we have a mobile app. And this one, so what this does, it might be sort of obvious, but here's an endpoint, right? And actually, this is mobile 1, so these endpoints that can actually be versioned. Because one problem that you have releasing an iPhone app is that if you want to make changes to what the API looks like, you have to version them. So this is the version of the endpoint. Here we have an example of what the result of this endpoint is. Here we have what parameters that are checked of the input. So these functions are actually run on the input and verify that there's an email that's a string and that there's a password that's a string. This validates the result of the output. And then this is a function that's run, and these are the parameters that are named there. Now, one thing that's actually really nice about this that we realized is, so we wrote our endpoints like this. And then came time to outsource our app development, and we had to describe what our API was. Well, what we could do was modify this form to generate a nice human-readable representation or description of what our API was. Not only that, but we had these examples. Not only do we have these examples, but every time that we compile our app, these examples are validated against the validation functions here. And so it ensures that they're all up to date. So this is one example that sort of forces you to have code that communicates what it's doing. Another example that we've created is a notification, sort of DSL. Notifications are a little bit hard because they're hard to test. Right? It's hard to test predicates about users when they're in certain states. You don't want to be accidentally send 10,000 emails to people that don't want to receive them. You don't want to send 10,000 users to one person that doesn't want to receive them. So it's important to build something that you can test and describe actually what the logic is in a simple way. So here, for example, we have a successful payment notification that has several modalities. So one is an email, one is a web notification on the web app, one is a push to your mobile device. And we have some additional forms here that say, OK, well, only send this at most once per successful payment, right? And this may be a little bit more complicated. It may say, well, don't send more than 3 notifications to a user in a given day, or whatever else. But this is, the point here is that this is actually a human-readable description, and that these things not only are predicate functions, right? So it's a little bit different than writing a Django or a Python class that has has a method meets limit, right? Because that's a little bit like a sort of a slot that your class can fill in. It's a little bit like a framework for notifications. This can actually do stuff outside of that, right? Each one of these forms can do stuff. And so, for example, one thing that this form does is it registers this notification on a global list of notifications that you can actually browse to while you're developing them and changing the templates and see emails rendered with real data that had been sent out the night before. So you can, if you want to modify the structure, you can actually see what it looks like with real data. Another way that we sort of promote code as communication is, or one tool that we use is that we can have syntax that's at the same level of the language. So, why should there be privileged syntax? Well, in other languages like Python, you can always see where the if is, right? You can always see where this is because it's kind of privileged. It's used in a different way. So here are some examples of ways that we've modified the syntax or sort of adopted or extended the syntax. So I mentioned defn before, which defines a function in Clojure. We've built these forms, these plus forms of each of these functions that actually do, that log their inputs and they log their outputs. So how many people have here written an if statement and then you write a little println that says, I am in this branch or I am in this branch? That's a very common thing to do. So here we just wrote if plus that says, write what your input was, write what the result of the predicate function was, and write the branch that you took and what the result of that was. Same thing with this function here, this function which multiplies by 3. Writes its input, writes its output. And actually that's really powerful because what you can do is you can save those results if you have some function that you're particularly concerned about, save those results by over one night of everyone logging into your website, change the code the next day and see what percentage of those invocations change or what percentage of those function values have changed. So it's kind of a way of, this is kind of a way of building up a real unit test, sort of generating your own unit tests. Okay, and I think this might be one of my last slides because I'm running out of time. But one thing that's really important, I think with Clojure, and this is true of other languages too, not just Clojure, but one thing that's really important is humility and convention on your team. So Clojure is a powerful language. And this is a common, again, this is one of those common things that everyone says that like, oh, well, once you build enough Lisp code, no one can understand it except the crazy long-haired guy that wrote it. But this is a way around that. Right? And it's really important that you hire people that are willing to work with you, right? And that are willing to work with other people. That's true of all code, right? It's not just true of Clojure. But so some of the things that we instill, right? This one is kind of copied from Google. Code should look like the code around it. If this code is not following convention necessarily, well, you should adopt that whatever convention that code is using. And at Google, for example, they had tests. You couldn't submit code on your own until you actually passed sort of a readability review. And in general, it's important that everyone sort of be humble. You agree to the forms as a team, you agree to the conventions as a team, and you enforce them. So for example, Clojure would allow you to make a function out of any Unicode character, right? So someone can say like, hey man, I can make a snowman function and like apply it to this variable x, right? And it's like, just because you can do something doesn't mean that we should allow it or that you should do it, right? So that may not be a good idea. And I think I'm going to stop there because I'm just about out of time. I apologize for that. But in general, I think Clojure is great for non-trivial apps. If all you're doing is reading from your database and generating templates, then something like Django Ruby is probably right for you. If you can find plugins that do exactly what you need to do and the percentage of code that lives within your framework is actually quite large, those would be great solutions. When you have a vast problem that you're trying to tackle and you're going to be working with your code for a long time, I think Clojure is a great choice. It really makes some tricky things simple, so I didn't get to them, but especially things dealing with concurrency, Clojure really has nice formalisms around that. You've probably heard about some. And convention and culture is really important if you choose to adopt Clojure in a team setting. And use the expressiveness of the language to make it readable, right? And to solve some of these problems that people have talked about with Lisp in general. And to solve problems within your own team. So you saw examples before of, well, we saw this bug was happening. How can we make it so that we can address these problems without crazy new frameworks or crazy new abstractions that we have to learn? How can we sort of just do it in line? And so anyway, not all of this, some of this stuff can be done in other languages too. I think one thing that's kind of important to realize is that all these things sort of build up And as you're in the flow of programming in the REPL, all these things sort of come together and really just let you stay there kind of uninterrupted by like, oh, great, now I have to go develop this other thing. I mean, it's actually a really powerful, enlightening experience. So I urge you to work more with it. And I think that's it. Thanks.